Okay, but in this paper, I'm just going to revisit this real quick so we can see what I'm talking about. All right. Intention, invention, adaptation. Intention. A lot of the ways that you express intention can be through code, but you can also express intention through specifications. That's like how people express intention for programming languages. Programming languages that are standards are specs. They're specifications on what the language should do. And then the compiler writers provide an implementation of that specification. The specification is all natural language. All right. So we go back to this thing. This is natural language. This is spec. This makes logical sense. All right. Now, just because something makes logical sense doesn't mean people are going to want to use it, especially when you're actually asking them to think critically and serially and in a systems 2 type thinking. Like this is hard, actually, right? So I'm being totally serious too. This is not a joke. I want to roll this back. By the way, I absolutely agree with what Amazon is doing here in terms of the advancement of science and the way that this should work, I think, from an academic and a more rigorous engineering perspective. This is a lot more rigorous. This, I think, will lead to the future. However, in the interest of being fair, this is fun, nonsensical playing that doesn't require you to have a brain. So a lot of people, I think, enjoy this because you just start typing some stuff and then some stuff just happens. And you kind of are just like, cool, I'm just going to write more stuff and more stuff is going to happen. This is going to require that you think deeply because your specifications, I mean, these are essentially first principles. You're essentially saying exactly what the system should do, how it should behave, what the just sort of core tenets are. All of this stuff. It's sort of like what it should do. And sometimes in the specs, there are explanations of why it should do it, but you don't specify how it should be done. You specify what should be done, but you don't specify how. And then the implementation is the how. And also keep in mind, this is quite beautiful because the spec is your ground truth. Your spec must be followed. You can't deviate from it. You must implement the things that it's doing. But as we know from code, you can implement an idea in so many different ways. Now, you should be able to test whether or not the ways that you did it actually are logically sound, like it makes sense. But as long as it does, there's no deterministic solution here. There's no saying there's only one way to do this, and it's this way, which is how I did it. So using a stochastic AI for the creativity on different ways that I want to implement parts of a specification, absolutely. 100%. This makes a ton of sense. This actually is the closest to, I think, outside of like Mentor, I think this is one of the most promising directions of using stochastic AI in a way that is scientifically sound. This makes perfect sense. And keep in mind, too, that specs in the past, they're also written by humans. They don't use like strict formalism that you would see in software code. So they're constantly not correct. They're almost never perfectly correct. That's why you tend to have errata in things like the programming language specification, or you'll have updates, addendums, right? That's to fix the bugs in the spec, right? Because it's just natural language. That's it. Some people sat around and they thought, this makes sense, right? I think it makes sense, Bob. What do you think? Okay, Fred, that makes sense. What do you think? Amy, yep, looks good to me. Okay, we all kind of agree. Push it. That's not a super great way to do this, but that's the way that it's being done. Truthfully, I've been on these committees. This is how it works. And so this is probably going to be at the level of that, if not better. And then this is the level of abstraction. This is like a meta prompt, right? Don't write the actual code. Get the specs, have the system work with you on the specs, and then the system can then take those specifications and stochastically build them in the implementation. Brilliant, 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 brilliant. That part I love. The part I don't love is that's hard. That's the opposite of like this toy little, I just get to turn my brain off and chill and just type a whole bunch of stuff and then I press some buttons and like check out these cool pictures. Like that's kind of the way that the vibe coders I think are trying to move forward, is this whole space of like, I'm having a really good time just chilling. It doesn't even feel like work. Part of the reason why it doesn't feel like work is kind of not exactly work. I'm telling you right now, without even having used this, this is going to feel like work, because these specs will have to make sense and you'll be working like spec 1.1, 1.2, 1.3. Do they all work in tandem with each other? Do any of them contradict each other? Like, this is system 2 long division type thinking. It's going to take quite a bit of work to get right. And so while I strongly agree that this is like scientifically sound, engineering sound, and I absolutely love the level of precision and clarity and correctness this is likely going to bring, this is almost the antithesis of this. Now, if they can find a middle ground, I will play with this once I get some time. Maybe I'll start fiddling with it this weekend, and then if it's looking good, I may shift the thumbnail generator vibe project over to here to see if we can level it up and see what we get. But while the scientist in me absolutely loves this, the professor in me absolutely loves this, the CEO in me that says we need to build a product that people are going to love, that they're going to be willing to pay money for, this is the part that I think you potentially struggle with, because this is work. This is going to require thinking. And it's not going to be, I mean, even Mentor's easier than this, because Mentor, like, it comes in, all you do is click add the repo, and then Mentor does all this for you. So you don't have to think that much. By the way, I'm all for thinking. I'm just saying, like, there's a lot of people that, of the vibe coding especially, it seems as though they want to turn their brain off, and you kind of want to work within the parameters of what they need. So you can keep your brain off. You don't have to do much. You're clicking on stuff. It's just bringing up some stuff. And then you're like, oh, yeah, this maybe isn't good code. Let's click on this. So again, all you've had to do so far is you're just clicking. I think anybody can kind of do that, right? You don't really have to think. I'm not asking you to write an essay or do any kind of advanced system 2 thinking. It's actually pretty simple. And then once you get into the code that has issues, Mentor is going to come back and explain this to you. Now, again, if you don't want to think, you don't have to read this. All you need to do is just go down here and be like, oh, right. Yeah, okay. Just, yeah, you put them in an array that has essentially these different elements. And then you just check on this. Oh, yeah, this is so. By the way, this is like an absolute baller solution. This should be upvoted like 1,000 times. And let me explain why. First, all you need to do is do this once. Just once. This here, I can almost guarantee you, this will have to be done a lot. It's not just going to be once. So let's see if I'm right about this. This is the key code left, up, blah, blah, blah. So let's go back and let's see if we see. Okay, so here's maybe the one we were looking at. This is like key code stuff. This is, oh man, Mentor's so good. Look at these numbers are the same. So basically, it's saying that these two. Sorry, I sometimes get even impressed by our stuff. Like this is the reason why I'm excited about this. Just to be clear, is these two lines of code are distinctly different. You can tell that these lines of code are not in any way like the same in terms of the syntax. This is a key code. These are left arrow, up arrow, blah blah blah. This is code. This is scan code, and like the number pad. Excuse me. How can you possibly argue that these would be equivalent? Well, when you don't look at this from a syntactic perspective, but instead you look at it from a semantics perspective, it's entirely possible that these lines of code are actually identical semantically. And in fact, I think 10, 11. Okay, hold on. Okay. Just give me 1 second. I'm counting these. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They are. These are actually semantically equivalent, not just in the operations that they're checking on, right? There's some inversion here with ands and not equal to, and is equal to and ors, but oh, whoops, sorry. No, I was looking at this line. It's these two lines. Yeah, these are these are perfectly semantically equivalent when you elide away the syntax. It's a comparison on some variable and a system constant. The system constant has no relevance. It doesn't matter what the system constant is. All you need to know is it's just a constant. It could be left arrow. It could be blue moon. Nobody cares. Left arrow, numpad, delete. That's irrelevant. What matters is the system constant against a variable. What I was counting is there are exactly 11 checks on this first one, and there are exactly 11 checks on the second one. So semantically, if you look at it from a variable and a system value, and you abstract away the syntax, but just look at it as from a semantic perspective, look at the meaning. This user variable is equal to this system constant. That's the meaning. That's what we're doing, right? And now that's the abstract concept. Then we drill down and make it a concrete embodiment, which is key code is equal to key code dot left arrow, right? So semantics are a higher order way to think about things. So semantics are like the specification to an implementation. So syntax is like the implementation level. Semantics are like the specification level. Not exactly, but like this maybe gives some sort of similarity. Anyway, so here you have exactly 11 comparisons, and even the Boolean logic is identical, and you have exactly 11 here. So these are actually semantically equivalent. Like you could write a we could write a mathematical proof that shows that these are semantically equivalent. And that is, I love that because I know how this works under the hood. And I know that Mentor, so you see how it makes they're both 737, but one has a 0 and one has a 1. So it basically is saying, I've looked at these two expressions and I believe they have semantic equivalence. That's why this one's 0 and this one 1, because it's saying the total semantic order in this expression is identical to this one. That's like a super powerful claim. And you can see other examples like here in this one, 891 and 0, 1, 2. And then you can look at these and you can say, oh yeah, these are the same. Same with these. But this one, these two are way cooler in my mind. These ones we can look at and just say, well, obviously they're the same because they're copy pasted. They're exactly the same, Goju. Yes, you're right. They are exactly the same. Even these ones are a better example of mentor flexing by not doing exact syntax matching, right? So it says these two are the same semantically, but you can see that this one's B is less than A and this one's A less than B. So those are inverted. These ones are perfect syntax matches. So the point is that even a system that isn't Mentor, a system that's actually pretty boring and not all that sophisticated, it would be able to see that these are semantically equivalent. But this one is it's so much harder. It's even hard for a regular expression system to do. I'm not saying it can't be done. I'm saying that there are complexities that can arise trying to do this where in this particular case, I might be able to write a regular expression that would flag this and would flag this, flag them both. We know we could do it here, right? Because this would not even require any variability. We could do it here because we could basically just try to say, like, I don't care, star dot end line number is less than star dot start line number. Okay, regular expression will work there. We've got it. This one doesn't work that easily because we've got a lot of variability here. Like these are wacky. It's just like, it's almost like string dot string and string, and that could work, I think. But the point of that is the way that Mentor does this, it doesn't do this. It wouldn't do it this way. And the reason why Mentor doesn't do it this way is this, it would understand is a system constant and it would refer to it that way. That's important because this dot may not exist, or there may be multiple dots. Like right now, this is just an outer global struct with a dot into a single struct inside of it. But you could imagine it could be key code dot English dot left arrow, or then key code dot some other language, whatever language we want to pick. We'll just say Spanish, Hindi, right? Something, this dot, this language dot, and now it's not left arrow anymore. It's something else. Or it could just be key code dot left arrow. So see how the regular expressions start to get much harder because you can't use just a dot as a placeholder. Instead, now it has to be potentially this entire string. But it's even wackier than that because Mentor will actually allow you to not just have strings here. It would actually allow you to have constants. So you could have literals in here. You could have the number 87 and it would still be like, yeah, it's the same thing. How do you do that with a regular expression? Like, I don't actually know how you would. I mean, again, I'm not saying that you can't do it. I'm saying like now we're starting to push the boundaries of regular expressions. Whereas if you build a semantic reasoner, like what we have in Mentor, this is significantly easier because it knows how to reason about this stuff. I can't explain. I'm not allowed to explain all the details, but I find this kind of stuff like super, super awesome. Anyway, so the higher order point we were trying to make is that Mentor allows you to turn your brain off or have your brain on. You do whatever you want. If you want to learn about all the cool stuff when you go into this, then you can read this description. You can level yourself up with knowledge, all that. If you don't want to do that, you can just jump to the end and be like, oh, here's the solution. Copy paste this. And now I'm going to drop this to my code. I've got the answer. When you go back over here, like, yes, you can vibe code. That's no brain. But to use this part, your brain has to be on. I'm at least based on my experience working on this, and I have worked on this many times, including working directly with standard C++ on what the, SG5. SG5? Yeah, SG5. Am I involved in this? Yeah, here I am. Okay. So what is all of this? Uh this is like a specification. I helped write this with many of the other folks on here. I think actually when we wrote this, just to be clear, and I'm not trying to flex on anybody, I just want people to understand. Uh, I think at this point, yeah, Michael Wong was the chair, and I was the vice chair, and that yeah, I was or maybe I stopped being the vice chair, but the higher order point is I was the chair of the specification for transactional memory before SG5, and then when SG5 got formed, Michael Wong took over the chair position because he's far more familiar and has a much stronger network with standard C++ committee than I do. Like I know a lot of the people, like all the people here and many of the other heavyweights in C++, but Michael's been working with them for like decades. So it just made a lot of sense that Michael would take over the chair position. Anyway, the point of all this is that I've done this stuff, and I have done this not just like I'm playing around. I've done it for like this language, for the standard, the ISO standard, to extend this language, that this was voted on by the standards committee, right? And oh, here we go. Is this it? For C? For C? We're doing this for C++. Maybe they did it for C as well. Oh, what have we got here? Okay. Really going down a rabbit hole here. Sorry, guys, but this is my typical meandering self. Uh, what's this one? Oh, okay. Standard wording for transactional memory support in C++. All right. So Victor, uh, Jan, I think is how you say his name, and Michael. Yeah. Okay. This is what a specification looks like. Mm-hmm. This is not easy to do. This document was worked on by all of these super smart people, and it took us a long time. I was working on this throughout my dissertation, and then I joined Intel in 2010, and I took over the chair position of the effort we were doing on transactional memory for standardizing it prior to it becoming the standard working group, the SG5 for C++. So that means by the time this document was written, I had already been working with almost all of these people for over 4 years on this document. Uh-huh. Yep. See what I mean? I mean, does this look like a lot of fun to you guys? I mean, I had fun doing it with all these folks, but this is not a joke, right? This is some serious, like, next level. You got to really be locked in to do something like this. So now, when we go back to this and we're looking at this thing, and when I say this is not easy, this is not like you're going to be vibing your way to ordering a pizza from Domino's and everything's puppy dogs and rainbows. This is going to be like you're exhausted mentally after doing this for 30 minutes and you need to stop because your brain hurts. That's what this is going to look like. At least that's my speculation in having done this type of stuff. Now, let me walk this back a little bit because I think I maybe overextended. It's entirely true that most things are not at the level of rigor. Doing a specification for an ISO standard programming language that cannot have bugs, right? I get it. Okay, this is maybe not like NASA level spaceship type of specification where lives depend on this and stuff, but this is probably a close second place. So why does that matter? The truth is, if I'm being fair, most specs don't need to be that good, right? Like if you're just building a program and your spec isn't perfectly like at this level, you might have a couple users that are like, it's supposed to work differently. That's cool. That's probably true, but it's not like the whole world is going to fall apart if it's not perfect. So I'm probably being a little too critical of this. I'm just trying to maybe give a fair view because to be clear, I love this. I love this spec thing. And in fact, I think it's one of the, as I was saying before, I think it's one of the first things I've seen that's actually moving science forward in this whole, I feel like I want to just call it the vibe coding wars. So maybe from here on out, we're called the vibe coding wars or the vibe coding hype wars. I feel like that's even better. Okay. I'm not going to talk for a minute and a half while we watch the rest of this so we can minimally get through this video. Zipped.
From generating a bunch of slop all at once. Rather than go straight to code, it encourages you to start in this requirements MD file, which defines things like the user story and acceptance conditions. Then once that plan is in place, it can move on to the design, which is the design document that outlines implementation details like your component structure, your testing strategy, error handling strategy, and so on. And then finally, those two documents get combined together to create an implementation plan. Each task will outline the code the AI should write, then you can click this button in the IDE to start it. Overall, the process felt a bit slower, but it does feel like a much more sane approach if you're building something serious or working with a team of multiple people. Overall, it feels like an IDE designed to appeal to developers working in enterprise, where things like design documents and consistent code quality matters. But currently, Kiro is closed source and only powered by Claude, but in the future, they plan to offer other models. Right now, Amazon is offering it for free, so using it's a no-brainer, but only time will tell if it becomes a legit cursor killer. But if you want to harness the full power of AI, you need to understand the math and computer science behind it. And
I think any of the companies that are like the Cursors, the Windsurfs, they're just UI wrappers for other people's models and other people's AI innovation. I think they're all cooked. And like I don't mean to sound dismissive or short. They have no technical moat, and it's not that hard what they're doing. They're just building the. Again, I'm not trying to sound like I'm attacking or being dismissive of their work. I think it's a cool idea. The problem is it's just scaffolding code, and anybody can build scaffolding code. which should be obvious because now Amazon has done it. And they're not the only ones. I think Google has done it with their thing, and all these startups are doing it. Now, the startups live in a fantasy world with a lot of the VC investments. So don't get confused for a second thinking that, oh, well, Windsurf just got acquired for 2 point whatever billion dollars. Maybe, but keep in mind that a large part of that is cognition stock, which basically means that unless cognition actually has a successful exit, and if you follow the startup space, there's lots of companies that have these ridiculous valuations, like the unicorn valuations for having done nothing, and then surprise, they totally tank because the valuations are coming from the fantasy world of whatever the VCs think they can just dream up and people will agree to. And oftentimes it's just the VC that's leading the round that's sitting around in a vacuum talking amongst themselves saying, I don't know, I think they're worth $2 billion. What do you think, Bob? I think they're worth 2.2 billion. What do you think, Amy? 2.3 billion. Okay, 2.3 billion it is. There we go. Is it decided? Did everybody agree? Okay, we agree. That's the valuation. That's how it works. And that essentially has zero relevance in the world today because it's only worth that much if someone is willing to pay that much. So now with the acquisition of Windsurf, you might be saying, well, Goju, didn't they get acquired for 3 billion? Well, as I understand it, first, I think it was 2.4 billion. The second is we don't know the specifics of that deal. Legacy media and the hype train known as like the VC media outlets like The Information, they're not going to generally present a balanced take on things. They're just going to present something that sounds very impressive and powerful. It's salacious. It needs to be sensational so people will click on it and then read the story. They don't do like Goju Tech Talk related stuff where it's more boring and we end up looking at things like a specification over here, or we talk for an hour about how this may actually not be necessarily a good thing in terms of ease of use, even though from a technical perspective, it makes a ton of sense for the advancement of science. So my view is that all of the vibe coding companies that are just building vibe UIs, so that's basically like the Windsurfs and the Cursors, and there's probably others where they don't really know anything about AI and they're not building novel technical approaches. I think Cursor said some nonsense about how they were like, they figured out some technical advancement to lengthen the prompt. No. And I want to share that I'm talking from experience here, is that one of my very good friends, Professor Tim Kraska from MIT, he a couple of years ago had his startup acquired. The details of the acquisition are private. They're closed. I don't even know the details. But what I do know is the technology, because Kraska and I and his key student, Ryan Marcus, was a student that I helped mentor. Tim and I did together. I don't know if we mentored him or Ryan mentored us, but whatever the outcome is, I was involved deeply in that technology. That technology is not scaffolding. That is not framework code. That is not something that is a UI around Git. That technology is technology that basically very few people in the world could figure out, which is why Amazon spent a lot of money to acquire that IP and get the team to bring it into Amazon so they could realize that tech. They could build some system at Amazon that will utilize it, which will give Amazon a step up that they didn't have. That is the kind of stuff that builds a technical moat. And again, it's not to say that you can't do this, but the likelihood that a bunch of folks that are not sort of the the world leading experts that have dedicated their life as a missionary to a cause that likely understand things at a very deep, visceral level beyond just sort of a lay engineer or mathematician or computer scientist. The people that have all of this deep training, those are the ones that likely will come up with novel technology that will then warrant a massive acquisition. The other guys, I think, unless you need the framework because you can't build it yourself, it often is not going to be worth these massively inflated valuations. At least that's my take. And there are some outliers where it's happened, but if you look at the details, oftentimes what's happening is the acquisitions are more just they sound super fancy, but they're significantly less than what something like The Information would report on. Okay. I lied. I didn't let it go for a minute 30. Let's try again and see if I can get it right this time.